Depth of field plays a very big role in photography because of its ability to focus on a subject and place every other part of the image out of focus. The result of this is an image where the out of focus part is blurred out. Photographers use this feature to shoot amazing photos such as portraits, selfies, and many other creative images. And when the autofocus area contains light sources, an interesting kind of image is formed, which is called bokeh. This effect can easily be achieved using a low depth of field lens on an actual camera, just like the one I'm using at the moment, but can also be achieved in post-production, which is exactly the purpose of this project. Before then, let's go through how depth of field actually works and how bokeh is generated on an actual camera. When we use a camera with aperture diameter of d to capture an image of an object on the object plane, the camera registers the image of the object onto the imaging plane, where the distance from the camera lens to the object on the object plane is a, and the distance to the imaging plane is a prime, which is approximately f. So basically, the focal length tells us the distance from the lens to the imaging plane that is in focus. From this, it follows that objects at different distances from the lens on the object plane will be formed at different distances on the imaging plane too, where change in z is the distance of the objects from the imaging plane. Objects in the object plane that are focused on the imaging plane will turn up as small circles, or better still, small points, and remain in focus because the diameter of the circle is smaller than the size of the pixel, while objects that are not in the imaging plane and out of focus will turn up as large circles, which also increases in size as the object moves further away from the object's plane. This results in cool portrait photos where objects further away from the subjects are blurrier, and if they contain highlights, we get to see the circles. This could be any shape, as it basically just reflects the shape of the aperture of the camera. Having understood how the camera handles focus and out of focus objects, depth of field can be defined as the range of object distances within which objects are in focus, or basically the distance from the nearest objects in focus to the farthest objects in focus in an image. The larger the depth of field, the more objects in focus, and the smaller the depth of field, the less objects in focus. The takeaway from this is that the depth of field increases as the focal length decreases, the object distance from the lens increases, and then the f-stop increases, which is basically the focal length over the diameter of the aperture. Now that we understand how this depth of field effect works on an actual camera, we can simulate the effects computationally in post-production using the application Bokeh Rhapsody. You can visit it using the link on the screen or find the link in the description below. The web application receives an RGB image to be blurred and a depth map. The depth map tells the application how far objects are from the camera lens. This application lets you select the shape of aperture to use. Once these images are uploaded, the application splits the depth map into 10 depth layers. You can adjust the focal length slider to set a depth value as the imaging plane. Any layer with this depth value will be left in focus. Having understood what depth of field is, the depth of field slider is a layer slice from the imaging plane layer. Any layer within this range is in focus, while the rest are out of focus. The f-stop, alongside the distance of the object from the imaging plane, lets the application know the diameter of the circles that appear on out of focus objects. The smaller the f-stop, the larger the diameter of the circle. The final output is an image with the out of focus area blurred using a filter with the specified aperture shape and based on the distance from the image plane. Here are some results of using this application in post-production. performance of generating shallow depth of field using depth images is heavily dependent on how accurate the depth maps are. Thanks for watching.